All right. This was up on Moodle before spring break, but it's also there in today's materials. Is the p.csv file, so you need to download that and put it someplace on your computer where you can find it. And if you attempted the analysis over spring break, then pull that file up, whatever you've been working on. You can begin with that. I'm going to begin from a blank markdown file, so just to get ready for class, start pulling that stuff together. All right, did you guys have a good spring break? Did you actually take a break or did you work? Good, good. It's important sometimes to take a break. All right, first things first, if you already have a script that you've been working on, just leave that one open. What I'm going to do is I'm going to start a new markdown file. So when you get into markdown, it's always good to title your markdown file whatever it is that you're going to be working on. For me, this is P's analysis, and this is live because we're doing live coding. I'm going to create an empty document. If you just create a document, it puts a bunch of preamble stuff up there that's to remind you of things that our markdown does. But I'm just going to create an empty document that doesn't have all of that stuff in it. Just a couple of reminders that to insert a code chunk, I've got the codes written on the board over there. For Windows, it's Control-Alt-I, and for Mac, it's Command-Option-I. If you haven't been working in R Markdown in a little while, you've probably forgotten that. So what I'm going to do is, at the beginning, I'm just going to start loading packages. So remember that in Markdown, you can just type things in, and those are treated just like comments. And then when you want to insert some code, you just insert a code chunk. So for me, I'm going to go Command-Option-I. That puts a code chunk. It always gives you this R in the little squiggly brackets, and so I use this to give titles to things. The nice thing about this is if you look in your R window, let me make this bigger so you can see. If you look in your R window, you'll see right down here, it says chunk 1, loading packages. And right now, there's only one chunk that you've put in there. Well, if you title your code chunks, this thing becomes a table of contents. And you can navigate around your markdown file really easily by doing this. So what we're going to do is, in the past, I've been using Pacman to load things. So what you want to do is you want to do p_load, and then you want to load whatever packages it is that you think you're going to be using. In this case, almost always you're going to be using ggplot2. This is how we make our figures. We need rmisc because this is where a bunch of miscellaneous stuff is laying around that we need to gain access to. Car is a program that allows us to do things with analysis of variance that you can't do in base R. tidyr is basically just a package that helps you manipulate data. And then Agricola is one that you are probably not familiar with that does some things with post hoc comparisons that aren't found in base R. So you probably already have ggplot2, rmisc, car, and tidyr already installed somewhere on your machine. You probably don't have Agricola installed, but one of the nice things about Pacman is Pacman will actually not only load the packages that you're asking it to load if they're already on your machine, but it will also install anything that you're asking for that isn't already there. So go ahead and run that, and if it needs to install something, it's going to install it, and that's what it's doing right now. So I updated R since the last time I ran Agricola, so it is installing Agricola for me, so it should do that for you as well. When you get your command prompt back down here in the console, put your green sticky up so that I know that we're all on the same page. Yeah.
So I went to open our studio and I got this, and I kept getting
Oh, wow.
this. And this
Okay.
happened before with Dr. Judd last semester, and we didn't really know how to fix it. But when I tried, like, we downloaded it this class at work, but I just tried to re-download it and it didn't.
What the heck?
Yeah. So I don't know what has happened.
So it just quits unexpectedly, and you click reopen, and it does it do the same thing?
It does the same thing.
Okay, crud. All right. Did you download a new? Whoa. You have R working though.
Yeah.
So it's just R Studio.
Yeah.
Applications. You don't have R Studio unless it's stored someplace else.
Right here. Should I?
Oh yeah, dump it into there.
Okay.
Although that shouldn't really matter. All right, try opening it. All right, go and reinstall it. So delete that and reinstall it real quick. Orange tabs. What you got?
I just keep getting an error in low namespace X. There's no package called Pacman.
So you probably didn't install Pacman to begin with. So go over here.
Oh, just go reinstall right there.
Yeah, go over there. Go to packages.
Oh, okay.
And then just look it up and install it.
Oh,
yeah,
okay.
we used it in the past, and so.
I think I just got it installed, but it was weird. I had to click like this green arrow thing instead of just going Control Enter. It's like when I was clicking Control Enter in here, it wasn't doing anything, and then I had to click this.
Oh, put it on the line.
Oh, like this? And
Yeah.
then if I had gone Control Enter, then it would have been fine.
I suspect so.
Okay.
Yeah, it looks like it.
It looks like it loaded though. Everything looks like it's good.
Yep. Yeah, Elizabeth, what you got?
I know I'm really behind, but I can't get this to open with R. Like, I can't get it to open in R Studio.
Okay, we're not there yet.
Like I don't even need to have this open.
No, we
Okay,
haven't. That's the data file.
Okay, I thought I needed to like open it first.
Nope. But you might want to click there to give yourself. Yeah, now you have editor and the console is both visible. Yep. All right. What do you got?
It's saying that this package is not available in my version.
Interesting. All right. Don't worry about it. We won't be using that for a couple of days, probably.
Okay.
I'll have to see what has happened. Do you have a relatively recent version of R?
I thought I had the latest version, but apparently not.
Okay. Don't worry about updating it now, but maybe between now and Wednesday, just update
Okay.
R and see if that fixes that. Did you re-download? Reinstall? It's working now? No.
It's still down.
Oh, it's still done. gosh, how slow can it be? All right, just cool your heels for a minute while Clara downloads our studio because she's having some difficulty with our studio. For Clara and anyone else, what's the next step that you want to do? Yeah. Yeah, the next thing you would want to do is you would want to read in your data file. I'm going to get tired pretty quickly of this thing putting output in my editor, and so I'm going to go down here and I'm going to under the little gear here, if you click on that, it gives you a little drop down menu, and you can put the output in line, or you can just have it put output in console. And when you do that, it'll keep your editor clean, and it will just put all of your output down below so that you don't have to keep scrolling around to get to your code chunks. So the next thing that you're going to want to do is you're going to want to read in the data file. Whoa. It helps to keep track of which window you are in. Did the same thing? All right, where did you go to where it downloaded it to? So it's right there. So you downloaded it, and then did that give you an install? No, it didn't give you an install. All right. So that's, click on that. Oh, that is that, okay. All right, drag it to applications, but I think it's going to have all the same result. There it is. So you've got base R. Try opening that. Okay, Yep, open. See if it does it. Right, it's doing the same thing. All right, work on Windows for this session, and then schedule a time for me to come by, and we'll try and figure out what's going on.
I can't get the same message you're sending over there, but it's not available.
Okay, yeah, so between now and Wednesday, update R. We're not going to need Agricole this early on in this stage of things, so just update R and then try and load it again
But is
and see.
everything else fine?
Go down here. Did you get command prompt back? Yeah. Yep, you're good. All right. Clara, let me know when you're up and running. Oh, you can just type it in. Just go outside of your code chunk. Yep, right there, and just type. If you're in R Markdown, yep. And then hit return a couple times. Give yourself a space. Just like go to line 9, and now insert a code chunk. Command Option R. Command Option I. Yep. And now give your code chunk a title. Where are you at? Oh, you're still logging in. Yes, ma'am. Just so you lost one of your little deals there. Undo.
Like erases?
Yeah, just erase that whole thing. So insert a code chunk. Give it a title. Just loading packages, because that's what you're about to do, right? So go ahead and put in your Pac-Man. Oh, it's not up there. Pac-Man, then 2 colons, and then P-load. P underscore load. Open parentheses, and then the packages you want. Clear? Are you up? Yeah. Okay. All right. Now the keystrokes are going to be different from your Mac, but just so it's Control Enter rather than Command Enter, and then the other shortcuts are on the board. All right. So now when you're down in this line, okay, you don't have Pac-Man installed, so let's go over here to Packages and type in. There you go. Yep. Now it should run. You have 2 C's in Pac-Man. Spelling errors are the bane of my existence. Okay, so now go to the end of this line and then click return, and it'll give you comment lines.
It still says it's not found, but is that just the old one?
Well, that's weird because it's right there. I mean, it's loaded. Oh, 2 colons. Now try. There it goes. All right. Now go to, anytime you're at the end of a code chunk, just hit enter and it'll get you out of that code chunk.
And then if they have to install those.
That's fine. You probably need to update your version of R. But do that between now and Wednesday. Clara, are you with us yet? What the heck? Oh, it's just slow. Okay, all right, good. Okay, so you need to go and get the data file downloaded onto this computer. So you need to go to Moodle. Sorry about the wait. Sometimes this takes longer than we expect. Thank you for your patience. I feel like I'm at a call center. Your current wait time is 9 minutes. Austin, you're running out of power. So Clara, then save it in your workspace someplace, but make a note of what the path is to that because you're going to need that. So go find, is it in your downloads folder?
Yeah.
Okay. So just work out of your downloads folder. Go back to the piece. Right click on that. Go to properties. Copy that path. Just copy it because you're going to need it here in a minute. All right. So before you go to read your data file in, it's good to know whether or not you're in the right directory for reading in your data file. And so I always check my directory. What command do we do for that? Get WD. And it will tell you whatever your directory is that you are currently in. So for example, on my computer, I am in my workspace, this course's materials, and the March 21st materials because today is March 21st, and that's where I have my data file. So either you can continue working in the directory that you're in, even though your data is found someplace else, or when you write the command to go and get that data file, you have to put the path in to that data file. So for me, what is the thing that we need to do in order to read in the data file? What command do we use? Read.csv. So I'm going to have it read in, and I'm going to have to store it as a shorthand. So my go-to shorthand is DAT, and we can use the assignment operator to then read in the CSV file. And in this case, all I have to do is put the open quotes in there and then put ps.csv because I happen to be working in the directory where my data are. And when I do that, it should read in the data file just fine. If it didn't, if it's giving you an object not found, you're working in one directory and your data file is in another directory, you need to get the path to that directory and either go and get it there, or you need to change your working directory using setwd. Yeah.
So I tried to change my working directory, and it just gave me this error message that says, you
Ah.
cannot change it.
You're on a Windows machine and you did forward slashes and they need to all be backslashes.
Oh, okay.
What's the error message for you?
Oh, are you on Word or you're on Mac? The assignment operator is option dash. Yes, ma'am.
So how would I switch it to where this is?
Okay, so iCloud Drive. Try just grabbing that whole thing, that whole path.
Copying it?
Yep. And now go down here, return, set WD, and then I think you have to put that in quotes, if I'm recalling correctly. No, highlight the whole thing, and then put it in quotes. There you go. Okay, now try reading that in. Oh, I think it did it. Okay, all right. So get rid of Macintosh HD. Oh yeah, and the other thing is, for whatever reason, it is done this, and this should all be forward slashes. So every time you see this little arrow thing, put a forward slash. Try that. Oh, and also put the whole path in quotes.
Oh, so it can't change it.
Hmm?
Office cannot change working directory.
Well, yes, you can change working directory. Why did it not do it up there? Oh,
Because I wasn't enclosed.
so you were already in Elizabeth Wilson. So when you told it to change working directory, all you needed was the end part. Yep.
Okay,
So
interesting.
actually get rid of this line here because you don't need it. All right.
Great, thank you.
And there's, yeah, okay, yep. All right, yeah.
That's giving me equal size. I'm trying to
It's giving me equal sign.
Oh, it's giving you an equal sign.
Yeah.
Ugh.
I don't know why.
Okay, I don't know why it's not working. Just do, you can also just do it the old school way. Whoa. Oh, that's, that. Just do the keystrokes.
Okay, just do that.
Yeah, just do the keystrokes, yeah, sorry.
It's the same thing with whatever's there, an equal sign, something like that.
That's weird, because he's on a Windows machine and you're on a Mac.
You know.
Okay, just do the keystrokes then. Just type it in like a normal human. So it's just a less than sign and the dash. All right. Has everybody read in their data? How do we check to see if it did it? Pardon? So one of the things you can do is you can look at this and it shows that it's read in. So in your environment pane, it should have everything that you've done in your environment. The other thing that you can do is you can either look at the first 6 lines using head. Remember that you can also look at the last 6 lines using the command tail. And you can also view the whole thing if you want by just typing in dat. But that really clutters up your space, but you can scroll up and down here. You can see you have control. You have 2% glucose, 2% fructose, the 1-to-1 ratio of glucose to fructose, and 2% sucrose. You can also do capital view dat, and what it does is it opens up a new window where you have your data frame in a table that is separate, so you can just come back and look at it anytime because there is a tab. Let me know when you put your green tab up when you've explored those 4 ways of looking at your data. View, capital view. Just first letter caps. It's one of the few commands in R that has a cap.
Mine's not putting it in down here or anything. It's just putting it over here.
That's fine.
Okay.
It's because you because you're in an R script, not R Markdown.
Oh, I'd opened it as R earlier, I thought.
I don't know what to tell you. Oh, this opens it in a new frame. So go up here.
Yeah, but when I did this, like it was just opening like head and tail down here, like it's not putting it down here.
It's not putting it down here.
See? It doesn't do anything.
Oh, okay. Go up to here. So it's putting it up here.
Yeah.
So go to the gear and tell it to put chunk output in console. Yep, remove output. Now it gets rid of it up here, so you stay clean up here, and it should put it here. So now do head again, and now it appears down there. Yeah, it's just a settings issue. All right, one person. What do you got?
It just doesn't look like yours.
Oh, it doesn't look like mine. Did you download from today's folder? That is not from today's folder. Go to Moodle from today. Not March 9th, March 21st.
That's not what I did.
Just go back to, yeah, there you go.
Yes.
Yep, download that one.
Everything.
What you have it in wide format, and I've converted it to long format. Yeah.
I'm
Yeah.
I'm just saying, What's the difference between an R markdown and an R script? Why don't we get an R markdown?
I prefer R Markdown because it allows you to comment things out easily. Also, when you go to give it to someone, so if you're actually a data scientist out there doing data science, you're basically doing an analysis for somebody. And what they're going to want is they're going to want to know what the analysis is, but then they're also going to want to know what it means, et cetera, et cetera. R Markdown is really useful for that because when you're done with a script, you can print a nice version of it. You can print it as a PDF, you can print it as a Word document, you can print it as an HTML if you're putting it out onto the web. And what it has is it has these blocks of code, but in between the blocks of code, it also has the ability to write explanatory material in a much more fluent way than just doing a lot of commenting. So, for example, you see in my script that I'm writing that I'm occasionally writing comments within code chunks. If you were doing this as an R script, your R script would be commented lines using the hashtag to comment out comments embedded within all of this code. So it would just be a lot of codes with a lot of lines that look like this. That becomes really difficult to read if you're reading a 25-page output. If you're reading a 25-page output, it's nice to actually just have explanations written out between code chunks where it's easy to read the text and then there's the code chunk. That's only possible in R Markdown. So when R Markdown came out, I kind of resisted it for a while, and then I started using it. I'm like, oh, that's super useful. Because the other thing that it does as you're doing it is it not only embeds the code, but it also gives you the output in tabular form so that the person can see what was the code and then what's the output that the code generated, even to the point of I asked it to give me a histogram. This is what that histogram looks like. So when you turn in your report, so you're going to turn in a report to me. One part of it is going to be a written report. The other part of it is going to be your R Markdown file. I can scroll through your R Markdown file and look at the commands that you wrote, and then I can look at the output and verify for myself that that's the correct code because it gave me the correct output. And so that's the reason I want you to get in the habit of using R Markdown. Yes, ma'am. Yeah.
I did because
Okay. Okay. So run that previous line. Yeah, that one. What? Okay. Yeah, open the connection. Okay. So where did you store? So did you successfully set your working directory?
Yeah.
Are you in there? Okay, and that's where your file is, correct? Oh wait. Okay. All right. Let me see what kind of file it is. Make sure it's CSV. Yep, it's a concept separated values file, which is what it should be. Oh. No, you did that right. Oh wait, is this the downloads file?
Mm-hmm.
Oh yeah, okay, that's the problem. You need to put /downloads. Yep, that's the reason. Okay, try that. I believe it's capital downloads. Yep. Run that. Now try it. Boom. Check it and make sure that it did it correctly. All right, so green tab's down, or orange tab down. Did it do it, Claire? Get the head of it, make it sure it read it incorrectly. Okay, and the reason it didn't do view is the view wasn't capitalized. It's one of the few commands in R that has a capitalization in it. All right, cool. Green tab's down. So we know that we have our data file. And it read it incorrectly because it looks just like the data file that we've been working on in class. So one of the things that I like doing is I like working an example by hand first, and then going through and working the same example via the computer, because you already know how the file, how that data set gets analyzed by hand, and so it's interesting to then just look at it in R. So since we've been working for a little while here, let's go ahead and save just so you don't lose your work, because I hate losing work. You can name this file anything you like, but now it's saved so you don't lose this work. What's another way that we can get a feel for what's in our data? We've looked at the first 6 lines, we've looked at the last 6 lines, we've looked at the entire data set using the view command. Is that all we need to know about our data and how R is treating our data? No. What else do we need to know? We might want to know class. So we could type a series of class statements and get the class of the first column of data, class of the second column of data. What's a more efficient way of doing that? Not summary. Not summary SE. That actually does calculations on the data frame. It'll give you the class of every column in your data file all at once. Yes, str, which stands for structure. So let's do str.dat and get something a little more useful. When we do str.dat, it basically tells us that we have 50 observations with 3 variables. There's this thing, treatment A, that is just a holdover from how I was doing analyses a number of years ago. We don't really have to worry about treatment A anymore because I'm smarter than I used to be. Not a whole lot smarter than I used to be, but a little bit smarter than I used to be. It has the treatment, and it starts off with control, and it treats it as a character, which is what you want it to be treating it as. And then it has the growth increment of the growth of these plants, and that's an integer. And so the nice thing about structure is it tells you everything about your data frame all at one look, and you don't have to go through lots of different steps. Now, as Elizabeth said, you could certainly go through and use the class command, and it will tell you that treatment is a character. But of course, you would have to remember from your data frame that treatment was one of the headings of one of your columns, one of your vectors. One of the nice things about structure is it tells you what's the names of your vectors, and also it tells you how R is treating them. Everybody get that done? Yeah. All right, good. Now, when R looks at your data are structured in the data set that you created for this, because you think control is the control, that's the comparison group that you're comparing to. Then you have 1% glucose, 1% fructose, sorry, not 1%, 2% glucose, 2% fructose, a 1% glucose to 1% fructose, and then a 2% sucrose solution. And you have it ordered this way in your data frame because you're a biologist and you're thinking about this in weird biological ways. But when R sees this, it puts it in alphanumeric order. And so when it orders these variable names, it's going to put this one first, this one second, this one third, this one fourth, and this one last. And I don't want it to do that. So what I want to do is I want to force R to keep these things in the order that they are in the data frame. And so the way we do that is we basically tell R what to do. So I'm going to force R to keep variable names in order. Open up another code chunk. And for this data frame, because the data frame is already in the order that I want it to be in, the coding for this is actually pretty simple. And what I want it to do is I want it to take the vector dat $treatment. So this is identifying one of the vectors in the data frame. Get the assignment operator, and what I want it to do is I want it to treat it as a factor, but then I want to tell it how I want it to do it. Well, okay, let's do it this way. As factor, so I want it to treat it as a factor, and I want it to just treat the same vector as a factor now. So when I do that, I can then look at class $treatment, and it's now changed what was a character into a factor. But when we go and look at this, so we can look at what is in that vector using the term levels, the command levels. So if we want to know what levels are in dat $treatment, we can use levels, and you can see that it's done exactly what I said it was going to do. It has put the 1% mixture first, then 2% fructose second, 2% glucose third, 2% sucrose fourth, and control last. So that's the order that R is doing these things as. But we want to change that so that we force R's hand. So what we do, yep.
So why do we want to reorder them and make them as factors?
Because when I want to make a graph, I'm going to want it to do the graphics in a certain order.
Okay.
And so if I just set that at the beginning of the R script, then it just does that in that order from then on out.
Okay, and then if we didn't do that, it would be whatever order R decided?
It would be whatever order R decided, yeah.
Right, so it's just a way of cleaning up our data to make sure we get exactly what we want.
Yeah, kind of. So in this case, whoa, that guy is dead. In this case, when we go to make a graph, it would graph the 1-to-1 mixture here. It would graph 2% fructose here, 2% glucose here, 2% sucrose here, and the control over here. And that's fine, but if you're thinking about data as a biologist, oftentimes what you want to have first in a graphic is the control, because that sets, if this was the control, that sets a level of growth that is under normal conditions that you then want to compare everything else to. And then in this case, because of the question that these particular biologists had, they're interested in how do simple sugars differ from a compound sugar. So this would be 2% sucrose, but then they have two ways of doing simple sugars. One is just 2% glucose, 2% fructose, but then there's this 1-to-1 of the two, so it's still a 2% mixture, but in this case it's a mixture of two simple sugars, and these two simple sugars are the same two simple sugars that are in the compound sugar of sucrose. So for the researcher, there's a particular logic to how you might want to see the data graphed, or you might want to see a table of means or something like that. And so anytime you have that, you want to force R to do that. So for example, I'm working on a data set right now for an undergraduate research student. Anybody know Zach White? Yeah. So he's working on this project, and we have data that are collected from 7 different populations. And these populations start in Brownsville, Texas, in the south, down at the Texas-Mexico border, and they go north all the way to Oklahoma City area. And we want all of his stuff to be reported and all of his stuff to be graphed from south to north. And so we start with Brownsville, then we go to Port Aransas, then we go to Galveston, then we go to Gonzales, Texas, then we go to San Marcos, Texas, then we go to Nacogdoches, Texas, and then we go to Edmond, Oklahoma. And so that is not the order that those variables appear in the original data set. They appear in the order that we collected them, which was in Oklahoma, then in San Marcos, then in Gonzales, then in Brownsville, then in Aransas Pass, then in Galveston, then in Nacogdoches. And so what I have here is a command that basically puts them in order from southernmost to northernmost, simply because that's the way I want it. Because when he then makes a figure, and if the figure goes from left to right, on the left-hand side is the southmost, and on the right-hand side is the northernmost. Or if they're stacked, if we have a bunch of graphs stacked on top of one another, the southernmost one is at the bottom, the northernmost one is at the top. So as I'm thinking about a data set, I'm thinking not only about how the analysis is going to go, but I'm also thinking about how the presentation of the data is going to go in the end. And I want to be thinking about that at the beginning. You could go and do what we're doing now after you get an output, and you're like, well, that's not how I wanted things arranged. And then in that case, you would just write this line of code at that point.
Right.
But if you can foresee these things, if you can think about these things beforehand, you can just write it all up front. Get your data set, get your data frame the way you want it to be, and then from that point on, you don't have to worry about it any longer. And there are going to be plenty of times when you analyze a data set, you get a graphic for it, and you're like, that's not what I thought that graphic was going to look like. And then you have to go back and do things after the fact. The degree to which you can think about it beforehand, you're just a little more efficient and better off. So that's what I'm doing. I'm just thinking ahead at this point because it's good to think ahead. So what I want to do is I want to actually just copy this same thing. And except as factor, because it's already a factor, now that I know that it's a factor, I'm going to tell it what order I want things to be in. So I want you to take this vector, which is dat $treatment, that vector in the data frame. I know that it's a factor, but I want you to put it in the order that it's in. And so for this, we type in level, and then 2 equal signs, and then unique. And what you're basically telling R to do is, I have a vector in my data frame. I know that it's a factor, but I want you to treat this factor a particular way. I want you to treat it according to the unique identifiers that are in there. And what that does is it keeps the order in the order that it's in there originally. Before we run that, let's go back and compare that to Zach's script that I'm working on with Zach. This actually is written differently because I'm telling it that it has levels, and then I'm telling it the order to put those levels in, because I know that that data frame is not in that order to begin with. If I put levels equals unique, it would just put them in the same order that we collected them in. I don't want them in that order. I want them ordered from south to north. So I actually have to tell it what that ordering is. In this case, the data frame is already ordered in the way that I want it to be ordered. I'm just telling R to leave that ordering in place. So let's run that. And then check, whoa. Oh, I forgot levels. It's a plural levels. Okay. Oh, it's only one equal sign in this print. Okay. So now when we type in levels again for this, we should get the levels in the order that we want them to be in. Put your green tab up when you got that done. And it worked. How's it going? Yep, it did it. So now we have control, 2% glucose, 2% fructose, the 1-to-1 mixture, and 2% sucrose. just the way we want it to be. Yeah.
When did we set the order?
We are allowing the data frame to set the order.
Oh.
So in this case, I know because I set up the data frame a particular way. You'll also see this happens with me with the data. When I go out and collect data, I actually set up data sheets to collect data in the way that I know that they're going to go into a spreadsheet. That's in the way that I know they're going to go into the R script. And so a lot of times I have the data frame already set up in the order that I want it to be. And so I'm just, when I'm basically telling it levels equals unique, I'm just saying keep the order that is found in the data frame. As opposed to, sometimes logistics requires that you collect data in a particular order, but that's not necessarily the order that you want to display the data in, which is the case with Zach's data. And in that case, I can't say levels equals unique because I don't want it to take the order that is in the data frame. I want it to rearrange that order. And so then I have to say, take Brownsville first, then take Port Aransas, then take Galveston, et cetera, et cetera. So the coding is a little different when you want it to just take the order that's already in the data frame. Because what R did to begin with is R took the order in the data frame and rearranged it according to how it thinks it should be ordered. It will always think that things should be ordered alphanumerically. I don't want it alphanumerically. I want it to do the order that I want. I want it to do the order I want so much that that's how I set up the original data frame. And so this is just telling R, leave it the heck alone. I know what I was doing. I put it in that order. Leave it in that order. Which is different than, I didn't put it in the order that I wanted it to be in, but here's the order that I want it to be in. So then you specify it individually. We could have just as easily done this this way. But in this case, we would have put control, then we would have put 2% glucose, et cetera, et cetera. We could have gone and put it in the order, but that ends up just being the same order that it's already in which case you don't have to go through all that trouble. You can just say, use unique and say, leave it in the order that you find it. So it's just less prone to typos. All right, so the data are now in the order that we want it to be in. So we're kind of ready to start doing analyses. So the first thing that you have to do, because what do you want to do before you do your analysis actually in an analysis of variance? Yeah.
Verify your assumptions.
Okay, verify your assumptions. So those assumptions are? But the two that we test statistically are normality and homogeneity of variances. Now for each of these, we have to have a structure to the analysis because we're looking at the normality of each treatment, the variables within each treatment. For homogeneity of variances, we're looking to see if variances differ by treatment. And so the first thing that you have to do is you have to set up the model that you're going to use to divide the data up by treatment. So what we do is we actually set up the ANOVA model. How many of you went to R over spring break and remember how to specify an ANOVA model? You guys did take a break over spring break. All right. There are two ways of doing it. One is AOV, which stands for analysis of variance. So that's easy to remember. And what you do is you put the response variable tilde the classification variable or the treatment variable. Let's do treatment variable. and then you tell it what data frame it's found in. Okay? It's a tilde. In my keyboard, it's in the upper left-hand corner of the keyboard. So here we want to get a new code chunk. And in this case, we're just setting up a model. And so we want to do, I'm going to give this a shorthand. I'm just going to call it analysis. Get the assignment operator. And what we want analysis to be is we want it to be an analysis of variance where, in this case, is it growth? Yeah, growth is the response variable, and growth is being determined by treatment. And the data frame is the data frame DAT that we've already been dealing with. And when we run that, whoa, I put a period instead of a comma because I am ham-fingered after being gone for a week. When you run that, it should give you nothing in the box below. Put your green tab up when it did that.
What is that character in between growth and
It's a tilde. It's in the upper left-hand corner.
oh, this right here?
Yep, uppercase that dude. Yep. Green tab up when you got this to run with no errors. All right, good. Tabs down. Type in the word analysis. When you type in the word analysis, it basically does the thing that you asked it to do. It did an analysis of variance on the effect of treatment on growth in these pea plants, and it gives you things that you're familiar with. It gives you sums of squares, it gives you the degrees of freedom, but it doesn't do the actual statistical test. And so what you can do is you can type in summary of analysis, and when you do that, it will actually give you your traditional analysis of variance table, where it has it arranged by the source of the variation, the degrees of freedom, the sums of squares, the mean squared, the F statistic, and the probability value. So you've just run the ANOVA. But of course, we weren't trying to run the ANOVA. We're actually trying to test normality. Why do we want to run the ANOVA in order to test normality? If we test normality on each individual treatment by itself, we only have 10 observations, right? If you only have 10 observations, what's your likelihood of finding a difference between normality and not normality with only 10 observations? It's not very high. You don't have a lot of statistical power. So what do we get instead? We get the rather than running variation within each individual treatment, what can we do? Not the variation among. Remember that for testing normality, we're looking at where the sample mean is, and then we're looking at where each of the individual values are relative to that sample mean. What are these differences called? Called residuals. And if this is the residual for the control, then there's also a bunch of residuals for 2% glucose. And when we test normality, we're testing the distribution of those residuals around the mean. Well, if we're looking at residual value, which is just the distance of this value from the mean, this value from the mean, this value from the mean, for the mean of control, this value from the mean, this value from the mean, this value from the mean, but the mean is the mean of glucose. All of those residuals are now on the same scale. Distance from the mean, regardless of where the mean is. So what can we do to get more power in determining whether or not these data are normally distributed? We can get the residuals from each individual treatment and analyze that whole thing for normality. So now we have 50 observations for analyzing normality rather than 10 observations for normality. So how do we get residuals from an analysis like this? Actually, in this case, it's just residuals. If I could spell, worth a darn. Just go residuals, analysis, and what that should do is it should give you a bunch of numbers. And they should all be numbers that are positive and negative, because some residuals are higher than the mean, some residuals are lower than the mean, some of the residuals are really close to the mean. Higher than the mean, lower than the mean, close to the mean, lower than the mean, lower than the mean, higher than the mean, lower than the mean, lower, lower, slightly higher, very small difference lower. This is what a file of residuals looks like. And as we shift from the first data frame, which is control, to the second part of the data, which is 2% sucrose, the values of the residuals don't really change much because it's the residual relative to that sample mean. So now, rather than testing these residuals, these first 10 residuals, we now have 50 residuals that we can use for testing normality. So let's save these residuals. How do we make a new vector in a data frame? All of our R skills have atrophied over the break. We've done this before. Dat $, what comes after the $, in a data frame? The column heading. So let's just put a new column heading, .res. We're now making something new, so what do we need to use to assign what comes after to this? You use the assignment operator, and we just want to save the residuals from analysis in a new column. Run that, and then look at your data frame again by running head. And what you will now see is that there is a new column in your data frame that stores the residuals. So now you have all of your residuals stored in your original data frame, so you can use those residuals whenever you need them. And what we're going to need those residuals for is to run a normality test. Yeah?
Sorry, I forgot to ask. Are those the residuals from the sample means?
Yep, it's the difference from the sample means, not from the grand mean. No, because those would vary a lot depending on where the sample is located relative to the grand mean. This is within sample variance. So the whole reason that we set up the model to be the analysis of variance is that the analysis of variance relies on two forms of variation. Variation within samples and variation among samples. Well, the variation within samples is what we want to analyze with reference to normality. And so it already calculates all that for us. We just have to extract that out of the analysis. So now I'm going to say setting up the model and testing normality, because now we've kind of included both of these in here. How do we test normality in R? Shapiro test, and it should give you a suggestion. And what we want to do is we want to run a Shapiro test on the residuals column from the data file that we have, DAT. And when we run that, we find the W value is 0.96928, which is something that we've already calculated by hand. And the p-value is 0.2164, so we find that these are not significantly different from normal. So we've run a normality test, and now this normality test actually has quite a lot of statistical power because we have 50 observations rather than 10. And so when we say that this is not different from normal, we can say that with greater confidence than saying it's not different from normal because we had a crappy low sample size and we couldn't detect it as being different from normal even if it was. Everybody get that to run? Got that output? Save this R script or R markdown, whatever you're working in right now. Open it up when we get into class on Wednesday. This is where we will begin. The next thing we will be doing is testing homogeneity of variances. There's a homework assignment on the Moodle site in this week's materials. It's 4 problems. Each one of those problems is a relatively small scale ANOVA. You don't have to test normality and homogeneity of variances and things like that. Just do the calculations for running the ANOVA. 3 of them give you raw data. 1 of them gives you summary data, but from those summary data, you should be able to extract the sums of squares and all of that from that. So work on that. Turn that in Friday morning, beginning of class. Yes.
Is that in our script or is that on paper?
On paper. Actually, I've given you tables that you can fill in the data. Yep. Fill in the calculations and everything. Yes, sir.
What is the p-value again?
P-value, it's your type 1 error. It's your observed type 1 error. So it's the probability of saying that it's not normal when in actuality it is. And so it's above 0.05. So you want to always be testing at a 5% confidence interval, or a 95% confidence interval. So that means a 5% type 1 error rate. If it's below 0.05, you would say it differs from normality. If it's above 0.05, you would say it's not different from normality. Yeah. Just a review. Yeah, when do you want to come by and do that?
I can come today, like from 1:40 to like 2:30.
Yeah, I'll just see. I have class right before then, so
Okay.
I'll just meet you in my office after that class period. Yeah. Yes, sir.
I'll just let you know early, but I won't be here Friday.
Okay, then turn in your homework before you leave, or send it with somebody.
Okay.
Okay.